can every action be undone? If I take a brand new deck of cards and remove the 2 cards that are the promotional cards, and then simply shuffle them, or let them fly all over the place, is there any way that I can get them back to their previous configuration? Yes, as long as I knew where every card was before I threw them into the air or before I shuffled them, I could put them back in the same position they were. So in a way, that action is reversible. But we know that not every action is reversible. In real life, we encounter situations where we cannot undo what we did. In math, when you have a function that undoes what another function does, it's simply called the inverse of a function. But not every function has an inverse. Only special functions that belong to the set of one-to-one functions are functions that will have an inverse. When we defined a function, we said that a function was a rule of correspondence that assigned to each input exactly one output. For a one-to-one function, we are adding an additional restriction. Not only does it assign to each input exactly one output, but each output has exactly one input, which means that 2 x's cannot return the same y as in the case of the x squared function. Therefore, we already know that the x squared function is not one-to-one. Now let's take a few examples and see how this all adds up. When we look at everyday things, we're able to see which actions can be done in reverse and which actions cannot. When we're talking about algebra, it's not as easy to see. We have a definition called the definition of a one-to-one function, which allows us to check before we even start just to see if this function is going to have an inverse. It's not going to tell us what the inverse of a function is. It's only going to tell us if a function has an inverse. So let's go into the definition. A function is one-to-one if the following condition holds for all a and b in the domain of f. If f of a equals b, then a equals b. This literally means that if for any reason you plug in some number into a function and you get a result, f of a, you plug in some other number into the same function and you get some result, f of b. Now, if those 2 results are the same, then this function is one-to-one only if a equals b. It's a kind of weird definition, but let's take a look at how we can use it. So let's start with our favorite function, f of x equals x squared, and we're going to show something that we already know. The f of x squared function doesn't have an inverse. And why doesn't it have an inverse? In a previous video, I said if you take the horizontal line test of the graph of a function and you touch 2 points, then you can tell that that function is not going to have an inverse. That was the graphic approach. This is the exact same thing done algebraically, but it's pretty simple, as you'll see. If f of a equals f of b, then a equals b. So we're going to start with this statement because that's what they're giving us. They're giving us the if. If this is true, show me that this is true. Okay, that's good. Let's see. We're going to start with f of a equals f of b. That's what they gave us. Now we're going to take our f and we're just going to plug in a here and put it in there. So now we have a squared equals, for the other side, I'm just going to take b, plug it into my f, and get b squared. B squared. And finally, we're supposed to show that this can reduce to that. And if this reduces to that, we're good. If it doesn't, then this function is not one-to-one. So now let's go ahead and take the square root of both sides. And on this side, we get an absolute value of a. And on this side, we get the absolute value of b. In other words, what we get is 4 solutions. We get that a equals b. We also get that negative a equals negative b. We also get that negative a equals b. And we also get that a equals negative b. So we didn't actually have to go through all these solutions to know. All we had to know was that this did not reduce to a equals b for us to say this is not a one-to-one function. Let's take a look at another quick example here. F of x equals x cubed minus 7. The first thing we're going to do is we're going to write our statement, our if statement. F of a equals f of b. This is our given. This is our conclusion. F of a equals f of b. So now we're just going to plug in a here, put it in there, and we get a cubed minus 7 equals, and now we're going to plug f of b, so we get b cubed minus 7. And finally, we're going to simplify this and see if it reduces to a equals b. So we can add 7 to both sides. This cancels, and we get a cubed equals b cubed. In this case, we have no restrictions or problems about taking a cube root. So we can take the cube root of this side, the cube root of this side, and we know we get a equals b. And that shows that f of x is 1-to-1, meaning we can actually find an inverse for this function. That is all for today's lesson. Thank you for stopping by. If you like the video, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to put them in the comments below. Thank you.